VLSos here. This is a video lesson on limits, an introduction. We're going to introduce a new concept, a new idea, and it's going to be related to an old idea, but we want to make sure from the very beginning that we're talking about two distinct concepts, two different questions. And to talk about this new idea, this new way of asking a question, we're going to create a piecewise function and start with what's familiar. So we have a horizontal and vertical axis here, tick marks on the vertical axis of 1 and 3, tick marks at 3 and 6 on the horizontal axis, and we can call this our traditional x and f of x. Our piecewise function is going to have a piece that comes to a closed dot at 3 and an open dot at 3 that continues the function there. Now we need to separate what we're going to talk about to distinguish between these two concepts, these two different questions that we could ask about a function. We're going to start with the familiar. What is the value of the function here? And we put it in quotes and word it this way to imagine that we could be on this function as if it's a path that we could move along, and we can think about where we're going and where we are when we're on this function. We could imagine that we're a thinking bug, able to crawl along the function as if it's a path. So if I ask this question as a bug, what is the value of the function here at any location? Then I would get my answer by reading the vertical axis to find the value at any place in the domain that was defined. This is a familiar question. There's nothing new. And this type of question could be called value question. What is the value of the function here? We have familiar notation. Generically, if we called it the f function, at any place in the domain we could call a. F of a stands for the value of the function. We could find a specific value at a specific location, in this case f of 3, and we look at the graph. At 3 we have a closed dot and an open dot, but there can only be one value at any place in the domain, or else it's not a function. The value of the function is the closed dot, a value of 1. Nothing new with that. Those are value questions. But there is a separate and distinct new question with a new idea and a new concept. We could think, if I continue, and of course we're going to word this as if we're a bug that can think about the position of the function and the changes of the function. And this idea of thinking about these questions as a bug on the function is not new. It's been used for a couple hundred years to talk about these ideas. But if I continue this approach of me being on a bug on the function, walking along, what do I think the value will be? This way of phrasing this question is predictive. It's about continuing something right now and thinking about what's going to happen in the future or ahead on the path. So if I'm a bug and I'm walking along this function, I'm imagining if I continue this trend, the curvature, the way this function behaves, what height do I think I will be at when I get to any location in the domain? It's a very different kind of question. I'm going to phrase it in a slightly different way and specific to this bug on this function. If I follow this trend, the curvature of the function, how high do I expect to be when I get to 3 in the domain? So we're this bug, and we're moving along towards 3 in the domain. And if this function follows the trend that we can experience, we can see, how high do I expect to be when I get to 3 in the domain? And the answer to this question is, the question is called a limit question, and its answer is different than a value question. This question is called a limit. And the notation for a limit looks like this. LIM, abbreviated limit, as x approaches a value in the domain A of the function that we're working with, f of x. And the question that I just asked here about this bug and this function at this place in the domain could look like this. What is the limit as x approaches 3 on this function f of x? So where do we think we'll be? Well, if I continue this trend, it looks like I'm going to reach a height of 3. But we have another branch to this function, another piece. We could imagine that there's a bug on this other piece traveling to 3, just coming from a different direction. And if we were a bug asking the same question, if I follow this trend as I approach 3 in the domain, how high do I expect to be? And we expect that we'll reach a height of 1, which is different than the thought that this bug has. There's a difference between what side you're approaching from. So when we write this limit question down, we have to consider we're approaching 3, but also from what direction are we coming? At this location, we could be this bug, which is coming from the left. Or we could be this bug that's approaching 3 from the right. And these two limits, the answer to these two questions are different, because the question itself is not answered by the value of the function. We have to go back to the idea that these two questions are fundamentally different. So we do not decide the limit question by looking at the value of the function. That closed dot there has no bearing at all on the answer to these questions. Where do I think I'll be if I approach 3 from the left? Where do I think I'll be if I approach from the right? Don't look at that closed dot. We're talking about something different. So this question, the way that I wrote it down, this is a limit statement, but I have to add something to it to distinguish between coming from the right and coming from the left. And I add it superscripted right next to the 3. This is approaching 3 from the positive direction. A plus there means from the right. And I can write the other limit question as you approach x from the left or from the negative direction with a minus of the same function f of x. And the answer to these two limit questions are different. If I'm approaching 3 from the right, I think I'm going to reach a height of 3. If I'm approaching 3 coming from the left, I think I'm going to reach a height of 1. These two limits are called one-sided because you have to consider when answering what side you're coming from the right or from the left. Let's give one more example of these questions. We have another domain value here of 6. So we could ask the familiar question, what is the value of the function at 6? And we could write that down. F of 6 is equal to, appears to be 2. That's the value question, the familiar one. Now for the new limit questions. What is the limit as x approaches 6? But there's 2 directions. So I'm going to put a plus here, approaching 6 from the right of this function f of x. Now, to answer this question, I imagine I'm to the right of 6. I'm coming from the right, and as I approach 6 in the domain, I think I will reach a height of 2. It does not matter what the value of the function at 6 is. On the other side, I could be approaching 6 coming from the left, and if I follow that trend, I could write the question, what is the value, or what is the limit, as x approaches 6 from the left of f of x. And I think that I'm going to reach a height of 2 again. So these two one-sided limits, in this case, are equal. They're both 2. If our one-sided limits are equal, then we could write the limit statement, what is the limit as x approaches 6, without a plus or a minus sign. So in this case, not a one-sided limit. We call this an absolute limit. What is the limit as x approaches 6 of this function f of x? Well, because we think that we are going to get to the same height of 2 from both directions, then the absolute limit exists and is equal to the one-sided limits, in this case 2. Let's go back to our first example. We only have one-sided limits here. If we wrote down and asked the question, what is the limit as x approaches 3? No plus or minus. This is an absolute limit of f of x. What's our answer? Has nothing to do with the closed dot. But we have one-sided limits. One is we think we're going to reach a height of 3. On the other side, we think we're going to reach a height of 1. They don't agree, so we have no absolute limit. In this case, the one-sided limits are not equal, so the absolute limit does not exist. And again, it has nothing to do with the value of the function. This limit does not exist because the one-sided limits are not equal.